These are your quadratic application notes for day 2. Yesterday we worked on quadratic applications and we focused on finding a couple of key points on each parabola. The first is if you know an x value, how to find a y. If you know a y value, how to find an x. We also looked at maximums and minimums as well as x-intercepts. Today we're going to focus on the same material. The problems will actually be the same type of problems. You'll have to find the same pieces of information, but we're also going to show you how to use the buttons on your calculator and some of the features on the calculator to check your answer. In case you ever get lost, the directions are right here at the top of the paper, but I will show you how to do them in this video. Problem 1 says the height in feet of a volleyball t seconds after it is hit is modeled by the equation h of t equals negative 16t squared plus 48t plus 4. What we know so far about this equation is that it's in standard form. It's in the form ax squared plus bx plus c. We know that it's quadratic, so it's going to look like a parabola, and the leading coefficient is negative, so it's going to open down, and the y-intercept is 4. So if I come over here, I know that the y-intercept is above the x-axis, and that the volleyball is going to go up into the air, and gravity will pull it back down, making it look like a parabola that opens down. In this equation, the letter t shows up where you would normally see the letter x, and t stands for time, so your x coordinate is time. It tells us it's measured in seconds. And the y value is where h of t shows up. H stands for height. So your y value is the height of the ball measured in feet. Part A says, how high was the ball as it was being hit? Well, I know that the ball is being hit right at the very start of the parabola. This is where the time is 0 because we have not even started the stopwatch before we've hit the ball. So I can go to my equation. I can substitute 0 in for the time. And I will end up with the y-intercept of 4. Time is in seconds. Oops, sorry, how high? Time was 0. This is your height of 4 feet. Part B says, what is the volleyball's maximum height? Key word there is maximum. We know we're looking for a vertex, but it's asking for the maximum height, and we wrote down that height is the y value. So I'm going to take a look ahead. And part C is also asking for a maximum, which is the vertex. But part C says how long, which is our x coordinate of time. So I'm going to do part C first. I'm going to find time by using the formula negative b over 2a. B is 48. A is negative 16. Multiply the bottom two together and divide to get 1.5. This is a time, so in seconds. Then go back to part B and substitute the time of 1.5 in. Type that into your calculator and you should get 40 feet. And I know this is correct because if I go over to my graph, the maximum is the top point, the top of the parabola there. Part B was asking for the height. Part C was asking for the time. Part D says, how long does it take for the ball to hit the ground? So a couple of things we know. First of all, the ball's going to go up into the air and come back down and meet the ground right here. This is the x-intercept, and we know that in an x-intercept, the y-coordinate is 0. Or if it's hitting the ground and it's laying on the ground, the height, or the y value, is 0. So I'm going to take my equation and set it equal to 0. and I need to solve for t. I can try factoring. Real world problems are not the best to factor, so I'm going to do the quadratic formula. The opposite of 48 plus or minus the square root of 48 squared minus 4 times negative 16 times 4 all over 2 times negative 16. If you type the discriminant into your calculator, you get 2,560. And if I go back to my calculator and type in negative 48 plus the square root of 2,560, hit enter first and divide by negative 32, I get about negative 0.08. If I type in negative 48 and subtract the square root of 2,560 and then divide by negative 32, I get 3.08 approximately. So the negative one doesn't make sense to us in the real world, a negative time. It would be over here to the left of the y-axis, and that's before the ball's even hit. So that one we're going to just disregard and say that the time is 3.08 seconds. I can go to my graphing calculator and I can check all of these by typing the equation into y equals. Then I'm going to use x instead of t. And there was a note at the top of the paper that said you have to set a good window. So if I go to my window, I didn't need any negative time values. And in part D, I found the x-intercept was 3.08 seconds. So I don't have to go any higher than maybe 5. I can count by ones. The ball's not going to go below the ground, so we'll start at 0 for the y minimum. And in part B, we found that the maximum height was 40 feet, sorry, so I might go up to 45. I am missing a negative in front of the 16. And there's our graph. So if I want to check part A, I'm going to hit trace. I know an x coordinate is 0. Hit enter, it tells me 4. If I want to check part B, I'm going to use second trace. And we've done this before. We've used intersect. This time I'm going to go find the maximum, and it'll ask me for a left and a right bound. So what I need to do is just make sure my cursor's to the left of the vertex, which it currently is. I could hit enter right now. I'm going to get a little bit closer to it. And I hit it too many times. Maybe. I don't know. It's pretty close. I'm going to go to the left of it here, hit enter. Then it'll ask you for the right bound. So I'm going to go over to the right of the vertex. Anywhere over on the right is fine. Hit enter. The vertex should be somewhere in between the two arrows, and then you hit enter one more time. So it says my maximum is 1.49 repeating, which is basically 1.5. That's part C. And the Y value is 40, part B. That's part if I'm looking for an x-intercept, I can go back to second trace, and I'm going to select 0. You're going to learn that zeros and x-intercepts and solutions, and there's another word, roots, are all basically the same thing with some different notation. So I'll select 0, and it will do the left and right bound again. So as long as I'm to the left of the x-intercept, which I currently am, I can hit enter. I am getting a little bit closer to it right now. Hit enter, it'll say right bound, so I'm going to go past it over to the right side. Hit enter again. My x-intercept is between those two arrows. Hit enter one more time. Part D said 3.08. This shows up every once in a while. It shows up on some calculators, not others. It depends on the problem and what you typed in. This is basically 0. This is scientific notation saying to move the decimal point to the left 11 spaces, which makes this number so small that it's pretty much 0. Number 2, the number S of ant species in Kyle Canyon, Nevada can be modeled by the function S equals negative 0.000013 e squared plus 0.042 e minus 21, where e is the elevation in meters. So again, things that we know about this equation: it's in standard form, it's quadratic, so it will look like a parabola. The leading coefficient is negative. It will open down. This one has a negative y-intercept though, so this one's different. It's going to start down here below the x-axis, go up, and then come back down. E is in the location of where x normally would be, so our x coordinate is elevation, and it says that that's measured in meters. And S is where y would normally be, so our y coordinate is number of species. So part A says, how many ant species would you predict at an elevation of 1,000 meters? So elevation is our x coordinate. I'm going to take the number 1,000 and substitute it in for e. Type that into your calculator. It should give you 8. That's your number of species. Part B says, predict the elevations at which you would expect to find 10 species of ants. So we don't know the x-coordinate. This time it's giving us a y-coordinate of 10. And if I draw in a horizontal line that models the equation y equals 10, we see that it crosses the graph twice, so I can expect 2 answers for this problem. 10 is the number of species, so I'm going to substitute 10 in for S. There's no way I want to factor this one. We have a lot of decimals here. So I'm going to move the 10 over to the other side and use the quadratic formula. So E equals the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. If you type the discriminant into your calculator, you should get 0.000152. So if I go to my calculator and I type in negative 0.042 plus the square root, 0.000152, hit enter and divide it by negative 0.000026. I get 1,141.19, so about 0.2 as an approximate answer. And if I type in negative 0.042 and subtract the square root of 0.000152 and divide it by negative 0.000026, I get 2089.6. These are elevations, so they're in meters. Part C says, at what elevation do any ant species cease to exist? So cease to exist means there are not any of the species. So that means that our species, or our S value, is 0. So what I'm looking for are the x-intercepts on the graph. where the y coordinate is 0. And if I look at my graph, there are 2 of them, so I should also expect 2 answers here. So I take my equation, I set it equal to 0. And I am going to subtract, I'm sorry, not subtract, use the quadratic formula to solve. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. If I type the discriminant into my calculator, this time I get 0.000672. So I'll do negative 0.046, I'm sorry, 0.042, plus the square root 0.000672. Divide that by negative 0.000026. I have 618.3 approximately. And negative 0.042 subtract the square root of 0.000672 and divide it by negative 0.000026. 2,612.42. Again, those are elevations, so meters. If I go to my y equals and type the equation in, I have negative 0.000013x squared plus 0.042x minus 21. To set my window, I know the y-intercept is negative 21, so I'm going to go down to about negative 25. I don't know the maximum, so let's go positive 25, guessing. I can change it later if I need to. We won't have a negative number of a negative elevation, sorry. And our maximum, ooh, hold on. I have this backwards. The x-coordinate represents elevation. In part C, we found out that the x-intercept was 2,612, so I have to go bigger than that. I'll go about 3,000 and count by 500s. I don't know the max here. I'm guessing. Let's go up to 20. If I have to come back and change it, I can. There we go. So to check part A, I can hit trace, type in 1,000, should give me 8. For part B, I can go to my y equals, and we haven't done this yet. I have a y value of 10, so I'm going to type it into my y2, and if I go to the graph, it puts a horizontal line through there. Now we have a system, and I can go find number 5, the intersection point. So my cursor's on the blue curve, I hit enter. My cursor's on the red curve, I hit enter, and then I'll hit enter one more time. 1,141.2. And to get the second one, I have to go back to second trace and select number 5, but I have to get my cursor closer to the other intersection. So I'm going to scroll over here. So if I hit enter 3 times, I get 2,089.6. To find my x-intercepts, I do second trace and select number 2, which is 0. Get my cursor over here a little bit closer. although technically I am to the left of the x-intercept and can select any of these points. I'll hit enter, go past it, hit enter again, and the third time, 2612.4. And it takes me forever to scroll on this computer screen, so I'm going to hit trace and type in 500 so I can get a little bit closer to this other x-intercept over here. So second trace, select 0. My cursor is currently to the left of it, so I hit enter. I scroll over to the right of it, hit enter, and hit enter one more time. 618.3. Last problem. A skateboard shop sells about 50 skateboards per week for $70 each. For each $1 increase in price, about one more skateboard per week is sold. The shop's revenue can be modeled by the equation y equals negative x squared plus 20x plus 3,500. Again, I know this equation is in standard form. I know it's quadratic, so it'll look like a parabola, and the leading coefficient is negative, so it will open down. And the y value is at $3,500. Here's a general picture of my graph. I know that X is going to be the number of skateboards that I sell. And that based off of every skateboard, I'm making a profit or revenue. So part A says, what is the shop's revenue if no skateboards, so the X coordinate is 0, are sold? If I go to my graph, I know that's my y-intercept, so I'm going to substitute 0 in for the X value. And I will end up with 3,500. Revenue is in dollars. Part B says how many skateboards would need to be sold in order to maximize monthly revenue. So I know I'm looking for a vertex. How many skateboards? Well, skateboards are our x coordinate. So part B is looking for the x coordinate. I can use the formula negative b over 2a. So negative 20 over 2 times negative 1. Divide to get 10 skateboards. Part C says, what is the maximum monthly revenue? So again, vertex. But this time it wants the revenue, so that's the y value. So I'm going to take the x coordinate that I just found and substitute it back in. If you type that into your calculator, you should get $3,600. D says, how many skateboards are sold when the shop breaks even? So if a shop is breaking even, that means they're not making money, but they're also not losing money. So the revenue, or the y value, is 0. What I'm looking for in this one is the x-intercept. If I set my equation equal to 0, I'm going to use the quadratic formula to solve. So the opposite of 20 plus or minus the square root of 20 squared minus 4 times a times c all over 2 times a. If I type the discriminant into my calculator, I will get 14,400. If I do negative 20 plus the square root of 14,400 and divide by negative 2, I get negative 50. Negative 20 subtract the square root, 14,400. Divided by -2 gives me 70. -50 doesn't make sense. It's negative. I'm not going to sell negative skateboards. So 70 is my answer. If I go to check it, I'll type the equation into the y equals. I have -x² plus 20x is 3,500. My window is going to go from 0 to, part D said 70, so let's go up to 100. Count by tens. I'm not going to have a negative revenue, and in part C, we saw 3,600 was the max, so let's go 4,000. Part A was looking for the y-intercept. I'll hit trace and type in 0. Verifies it. B and C were looking for the vertex, so second trace, number 4. I'm to the left of it, so I'm going to hit enter. Scroll over to the right of it. Hit enter. Enter one more time. So this is rounded to 10 and 3,600, verifies parts B and C. And I can do two things. I can hit trace and type in 70 because that was the exact answer in part D. The y coordinate is 0, so it verifies it for me. Or I can do second trace, select 0, make sure my cursor's to the left, scroll it over to the right, and have it find the 70 for me.